Another important discrete probability distribution is the negative binomial distribution, and I'll be explaining all about this in this screencast. Up until now, you've considered the binomial distribution, where it's important that there's a fixed number of trials, and that's decided beforehand, and the independent variable is the number of successes in that fixed number of trials. The output is the probability that we get exactly x successes in n trials. We then talked about the geometric distribution. This is the number of trials. So now the number of trials is the independent variable that goes into the formula required to get the first success. And that's the important thing, is the first success. The output of the geometric distribution is the probability that we will get our first success in x trials. So now what we're going to do is we're going to extend the geometric distribution, and instead of being the first success, we're going to now consider getting r successes. So using the negative binomial distribution, we're going to be able to answer questions like, what's the probability that we will require 10 trials in order to get 3 successes? What's the probability that we will require 8 trials to get the first 4 successes? So let's just take a look at an example. Let's just say we require 3 successes. So R is going to be the number of successes that we require. And let's just consider x equals 5. So this is the number of trials. We've got x equals 5 trials, and we need 3 successes. The third success, in this case, the last success, is always going to come at the very end. So we can put successes there. And now we've got r minus 1 successes left, and we have x minus 1 trials remaining. You could imagine we could have a success here, we could have a success in the middle, a failure, a failure. We could have maybe 3 successes at the very end, 2 failures. We could have success, success, failure, success, success, failure, failure. So there's lots of different ways that we can rearrange those r minus 1 remaining successes other than the last one. Remember, the last one is always going to be a success, and the remaining failures in those spots. It turns out that the number of ways to do this is you take x minus 1 spots, and it's the combinatorial of putting r minus 1 in there. And so that's the different ways that you can combine that. This is similar to the binomial distribution, but let's first look at the failures. The probability of different failures would be the probability of failure, which is 1 minus p. If there are r successes in x trials, then that means there are x minus r failures. So the probability of failure is 1 minus p raised to the number of failures, and then we just multiply by the probability of success, and we have r number of successes. So this is the negative binomial distribution, the formula for calculating the probability that we will require 5 trials to get the third success, 6 trials to get the third success, and so on. So the negative binomial generalizes the geometric distribution. The geometric distribution is a special case of the negative binomial when r equals 1. So we consider x as the random variable describing the number of trials required to reach r successes. So we fix r, that's the required number of successes, and the negative binomial distribution tells us the probability that those r successes will occur in the xth trial. And as I just showed, the probability function is here. If you're interested and if you're asked to determine it, the mean and variance are shown down here. Those are also found in your book. So let's go through an example here, an extension of our Girl Scout cookie problem. We have a probability of success that any single house will purchase a box of cookies is 20%. And a negative binomial distribution problem would be, what is the probability that you will sell your third box of cookies? We're saying selling a box is a success. That means r equals 3 successes on the 8th house. So exactly on the 8th house. That means x equals 8. We can plug those values, those numbers, down into the negative binomial distribution formula. So we get 7 choose 2 times 1 minus 0.2. That's the probability of failure to the 5th power, because we have 5 failures. 0.2, that's the probability of success raised to the 3rd power. And when we do that, we end up with about 0.055. That means that the probability that you will sell your third box on exactly the 8th house is 0.055. Now, what about if we were asked, what is the probability that you will sell your third box of cookies before the eighth house? We still have r equals 3, but now we can get our third success in 3 houses. We could get it in 4 houses. We could get it in 5, 6, 7, and 8. So that would answer the question if we summed f of 3 plus f of 4, f of 5, f of 6, f of 7, f of 8. That would tell us the probability that you will sell your third box of cookies before the 8th house. So that would give us the answer to this question. So hopefully this screencast gave you a better idea of the negative binomial distribution. Thanks for watching.